We are live.
Okay.
Perfect. I think we're good to start.
Okay. Let's do it.
Yes. So, hi everyone. I can see there are already close to 20 people who have joined the session. This is one of it's kind of a session, and especially a lot of people have been requesting a session on basics of Frida, and we have two amazing speakers, Badsha and Abhinav, with us today, and I'll just pass it on to them, and they will get started with it. Perfect. Over to you.
Thank you, Vandana. Hello, guys. This is Abhinav here, and that's Bacha for you. We are equally excited to give this session, and because for the past 1 week or 10 days that we have been thinking about it, it has been a very learning. It has been a huge learning curve, and we have really had lots of fun. And today we wish to share the same with you. So, without further delays, let's actually get started. Let me share my screen so we can. Okay. All right. So, Vandana, can you see the screen? Just confirm that one so that we can get started with the stuff.
I can see your screen.
Okay, cool.
I can see you live also.
Sure. All right. So we'll be talking about basics of Frida today, and why are we giving this talk in the first place? Chandrapal and me both have had the opportunity to play with Frida in our past experiences. We have analyzed about a dozen apps, mostly Android apps with Frida, and we've explored a very small pinch of the power that Frida gives you, and it has been an amazing tool. It has been wonderful to work with it, and today we would like to share that same experience with you, and hopefully we'll be able to introduce you to this tool, and so that you can go ahead and explore it on your own. While we have been trying to learn this tool, we found it amazing, as we have already mentioned, and the primary reasons for that is because, of course, because of its awesome capabilities that it provides, and the amazing ease that it provides, with which you can play around with it. But more importantly, it is a very well maintained tool. It's in its 12.2.6 version right now, and has very active support from the community and also from the author himself. The author of this tool happens to be a guy who goes by the name Oliver. And without all of his support, of the community support, this session today would definitely not have been possible. So, yeah. Having said that, what exactly should we not expect from this session? Because Frida is a huge thing, and we possibly cannot cover every aspect of it. There are some things that we would not be able to cover today. So that those have been listed out here. We would not be covering the internal workings of Frida as to how exactly does it do what it does. We are not going to talk about Frida's use cases for any platform other than Android. We'll be focusing solely and wholly on Android today. Frida in itself has multiple modes in which it can run. You can make use of it in multiple modes. We will talk about the modes briefly, and the only mode that we will be focusing on today is going to be the injected mode. We'll talk about what exactly it means, but the other modes we will not be covering today. We are also not going to talk about older versions of Frida or any version specific details of Frida, so to say. And we, although we'll be going about talking about different demos, we'll have apps where we will be analyzing those apps using Frida. We'll not be covering. There are certain prerequisites required for the Android monitoring itself. For example, decompilation of the Android apps. We'll not be talking in details about them, but we will make sure to cover the very basics so that we are all on the same page. Also, at times when we are analyzing Android apps, we find obfuscated code, and as as security engineers or as pen testers, the first question that we all have at some point or the other that we have dealt with is how to bypass this obfuscation, how to make sense of this obfuscation. Although Frida has the capability to do all of that as well, we are not going to talk about that either today. And Frida uses a lot of JavaScript inherently. So again, we are not going to this talk is not going to be about it's not going to be any kind of a JavaScript primer where we will be talking about the capabilities of JavaScript or how exactly are the JavaScript functions itself written. But yeah, having said that, again, we will try to make sure that the basic idea or the logic around the JavaScript itself is conveyed as to the best of our capabilities, if not the syntax, right? Uh, with all of this in the plate right now, where we have talked that what we are not going to talk about and why Frida, some of us might have questions as to, if at all I need to continue watching this session any further, what are the prerequisites I need to have? Well, frankly, none is needed. Like, no prerequisite is actually needed. But having knowledge of Python, of JavaScript, and the basics of Android apps, the way they function, is going to be definitely useful, right? But if you don't know that, just don't worry about it. We should sail through. Oh, excuse me. Okay. So, what is the agenda? What is that we are going to actually talk about? We'll be talking about what exactly Frida is. It has been the buzzword for some time now. What exactly is it? We'll be setting up Frida on an Android device, and we'll be showing you how to do that. Reason being, if you want to go back and actually try it out, start playing with it, we will be talking about how to set it up. Frida can be set up on multiple different platforms. It is a cross platform tool, right? The one that we will be concentrating on would be to set it up on a Mac machine. We have tested out the same steps or almost the same steps on an Ubuntu machine as well, and it works perfectly fine. On the target side, as we mentioned, we'll be targeting only Android devices. We will be just basically touching on the Frida modes of operation, like what exactly they are, and we'll be deep diving only into one of them and explore only one of them, which is the injected mode. Going through the slides, we have managed to compile a set of demos, and hopefully those demos work, and hopefully those demos will be able to convey a good idea about what exactly are we trying to talk about, right? So, what is DBI and what exactly is Frida? If you Google around DBI, you'd find a lot of very complicated, jargons that are being used. The acronym itself stands for Dynamic Binary Instrumentation. So, what does that mean? Well, uh, let me try to draw an analogy here, right? Like, to understand what exactly does that mean. So say for example, if you let's say there's an organization and you want to know the internal workings of that organization, right? You want to know every single thing that happens inside that organization. What are the processes? Who are the people working there? What is the responsibility of each of those people, etc., etc. Now you yourself, not being a part of the organization and also not being the owner of the organization, it's hard. It's really difficult for you to know what exactly is going on inside that organization, right? What could be the possible solutions? If you have seen a lot of Hollywood movies, one of the possibilities is that we place a secret agent inside that organization, and possibly at a high ranked role, so he has enough permissions to get enough information. And because you have placed a secret agent, you can control that agent. You can ask him information, and he's bound to deliver that information to you. So you have actually went ahead and you actually gone ahead and planted that secret agent inside your organization to give all the details that you want and all the details that the agent is capable of picking up. That exactly is what is dynamic binary instrumentation all about, right? You have a process, you do not know what the process's internal workings are like, because you are not the owner of the process. You do not have the source code of the process. It's a closed source project that is finally running on your system as a process, right? So you want to know the internal workings of it. You basically send in an agent and ask all the information from that agent about that process. You inject another process into this process, into the target process, right? That is what is dynamic binary instrumentation all about. And Frida is one such platform. It's one such it's one such tool or framework that gives you the capability to do this kind of dynamic binary instrumentation. It helps you inject a certain process inside another process and gives you control on how the process is functioning or whatever it is doing, right? So that is the basic of what exactly is DBI and what is Frida. I remember, like, we mentioned that we are not going to talk about the internal workings, but if we are to look at a very brief note on how exactly does it do that. Frida basically injects the V8 engine or the duct tape JavaScript engine inside. V8 and duct tape, both of these are JavaScript engines, which means that without these are the engines that basically your browsers have, right? And if you want to run some JavaScript, you need to have these engines that understand your JavaScript and have the capability to execute them. So these engines are the ones, like one of these engines. Earlier it used to be V8, and if I'm not wrong, it is duct tape now. So Frida takes one of these engines and injects it inside the process that you are trying to monitor, the process that you are trying to do instrumentation on, right? That is on a very high level what Frida does and how it does it, right? With that in place, what is the kind of capabilities that you get? So imagine you have the entire JavaScript environment inside a running process, which means whatever JavaScript that you are capable of writing, you can write the JavaScript and pass it over to this engine to execute. Inside the JavaScript, Frida provides you capabilities to allow the JavaScript to interact with the process in which it has been in which it has been injected, right? So with this particular JavaScript, you can look through the entire process. You can look through the internal data structures of the process. You can go through the entire heap of the process, check out what objects are there. You can see the functions that are being called. They're all in real time. Whenever a function is getting called, you can take a look at it. You can see what is the arguments being passed to it, what is the kind of return value that the function is giving back. All of these things can be monitored. All of these aspects about the process in which the process can be monitored, inside which the engine has been injected. And Frida gives you capabilities to interact with the JavaScript engine. So this JavaScript engine is basically your agent, if we have to draw an analogy back again, right? So these are the various capabilities. I mean, these are just some of the capabilities that Frida gives you. Frida is a huge and it's a very vast framework. And, we will possibly be trying to restrict our talk to these small set of functionalities and try to explore them in greater detail to see what are the real world scenarios we can handle with them, or what are the problems we can solve with them, or how exactly can we approach some of the problems that we see with Frida. That gets us to the different modes of operation that Frida offers, right? So as we mentioned earlier as well, we are going to talk about only the injected mode, right? And that's nothing but what we have been discussing so far, taking a process and injecting it inside a target process that we want to monitor. That is mostly Frida is used like that, and hence we are going to focus our efforts today on that as well. And the other two modes that Frida offers is the embedded mode and the preloaded mode. So when we are talking about the embedded mode, Frida offers something called as a Frida gadget, which is nothing but a shared library, and with whatever process that you want. Yeah, okay, let me finish this. So whatever process that you want to monitor with Frida, you can take that process, you can pack the Frida gadget with it, and then you will have remote access to that process like you had through the injected mode. Now, why would you want to do this? Why not do it the injected way itself, right? So sometimes you might come across a situation where you do not have a rooted device, or you do not have say for example, if you have a jailed iOS device or a non-rooted Android device, and you still want to do this kind of stuff. In that case, you could take apart a certain app. For example, you could inject your Frida gadget inside the app. Rather, let's not call it inject, but you can build the app again. You can patch the app with the Frida gadget, build it again, and then try to deploy it on the device and try interacting with it remotely. That is exactly the kind of capability that the embedded mode offers. On the other hand, there's another mode which is known as preloaded mode. And by the way, these examples that I'm giving out, these are directly taken from the Frida website. So yeah, so if you look at the other mode of operation that Frida offers, it is called the preloaded mode. And it's something like, if you are aware of LD preload or DYLD insert libraries. So these are dynamically loaded libraries. So you can use Frida gadget or Frida, yeah, you can use Frida gadget as a dynamically loadable library that 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 can be taken advantage of by any of your processes, right? So those are the different modes of Frida. If you do not understand all of this very clearly right now, it's okay. Don't worry about it. As we mentioned again, like, we'll be just focusing on injected, and we'll be dealing with a lot more examples, hands-on, not really hands-on, yeah, a lot more examples and demos with the injected mode to give a sort of a clear picture about the injected mode, and embedded and preloaded possibly some other time, right? Okay, so if we want to play around with Frida, the first thing is that we need to have it installed on our systems. And Frida offers, pip packages that you can directly install. There are two most important packages that you would need for this. One is the Frida package itself, and the other is Frida Tools. Frida Tools being the more important one. Frida Tools is the one that provides the core libraries and the actual functionalities and everything. While Frida, the Frida library itself, it is the one that provides the Python bindings. While you try doing this, make sure of one fact, which is where we, at least Chandrapal and I, went wrong multiple times. It is to make sure that you have the right matching versions of the Frida library that you're installing on your host, and of the server that you're going to inject inside your on your that you're going to place on your mobile device, right? So for example, in our case, we have used uh, Android virtual devices, which is provided by Android Studio itself, x86 machines, and we are using the Frida version 12.2.6. So we have to make sure that the pip installs 12.2.6 on the host side, while we download the Frida server for x86 and 12.2.6 on the Frida server side, so we can take that and put it back. So we take it from this particular GitHub repo, which is here, unzip it, and then we basically, it'll be a long name, and we didn't want to use that all the time, so we renamed it to Frida server. And then we use adb push, which is a normal, which is a basic adb command used to transfer files from your host onto your mobile device, be it an emulated device or be it a real device, right? In our case, it's an emulated device. We push it to any location of our choice. We chose to go ahead with a standard location, as mentioned in Frida documentation in a lot of places, which is /data/local/temp. Once the file has been pushed there, we log into the device, and we try changing the permissions, because we need to run this binary, and this binary by default doesn't have execute permissions. So we change the mode to 755, and then we just kickstart our Frida server. Let me quickly give an a video demo of this, so we are aware of what it is. We are on the same page. Just give me a second. Yes. So as we were talking about it, we'll quickly see. Let me actually increase the playback speed here a little bit. Right. So that's how you do a Frida install. And if you look at it, we have had 12.2.6 is what we have installed. And that's the installation of pip installation of Frida-tools. After having those installed, we go about start our emulator. On my Mac machine, it happens to be present at this particular location. And if you can see, we have our AVD, booted up now. We would next go ahead and try to download, Frida from the right version of the Frida server from the link that I mentioned a while back. And once we have that version, so if you see, there are multiple different downloads available here. The one that we are interested in right now is the Frida server version 12.2.6 for Android x86. Right, and we unzip it. We simply pass it on to our mobile device. Oh, well, I think we changed the name as well. It's an XZ compressed data, so yeah, of course we have to decompress it. Right, now if you look at it after decompressing, it's an ELF binary. We change it to a smaller name, and we pass the Frida server now to our running device. So right now we have the emulator running, which is what the command adb devices gives us. By the way, these are very basic adb commands, guys. Adb is Android Debug Bridge. It is the utility provided by Android Studio, or yeah, I mean, it's a utility with which you can interact um, with your virtual devices. There we push our Frida server to the device at that location, which is slash data local temp. And if you look, we already have root permissions here, so we can change the permissions of the binary, give it execute permissions. We have given it execute now to the owner, and we start the server now. So you can either choose to start the server like that, or you could choose to start the server in the background running mode with an ampersand appended at the end. Now let's quickly check if we are able to interact with it or not. So if you look at it right now, we ran a command. Actually, let me go a little back. Yeah. If you look at the screen right now, we have given a basic Frida command, which is Frida-ps-u. We are giving this command at this point in time just to check if our Frida server is running properly or not, and if our Frida client, which is on our host, if it is able to talk to the server or not. That command that you see out there, Frida-ps-u, it gives you a list of all running processes, currently running processes on your device, and that's the exact output we see. So you see a bunch of a bunch of apps that are already running with their PIDs. So if you look at, say, there is com.android.email, which is running at PID 2524. You have gaps, which is running on 2043. Of course, you see the zygote, which is at 1346, and a bunch of these processes. So we are all good now. And of course, yes, we look at our Frida server itself running with PID 2928. So this with this experiment, we are sure that our Frida server was the right version that we downloaded. It has started successfully, and we are able to talk with it. All right, so let's get back to our slides now, and just a second, guys. Yeah, let's get back to our slides. So that was how we set up Frida, and now we will go about learning how to use it. I'll pass it on to Chandrapal. Chandrapal, please take the mic.
Thank you, Abhinav. Okay, it's great. Before we just jump into how to start Frida, how to get control of the application, what we are targeting, let's talk something about Android apps, because that's what we are targeting. Basically, if you are a developer, you would understand that whenever you start an app, it's called an activity. The screen which you look at is called an activity. If you see the life cycle of activity, it has multiple functions, predefined functions like on create, on resume, on stop, and all so on. So we generally try to hook or get control of those functions using Frida generally. Some people might have this question, okay, we are trying to move from Java to Kotlin. Will Frida work on Kotlin? The answer will be given in some time. Let's start on how to get control of the package using Frida. By the way, each Android application has its own unique package name, which is like this com.target.app. So something like com.bacha.chandrapal can be an app or something, whatever you're targeting. Now you can either attach or you can start the app and then attach. When I say attach, you're attaching or you're taking control of the functions which are in memory after the app was manually started by you. If not, if the app should be started by Frida itself and then attach and take over the control of all the classes and functions, then you specify this would tag -f, which will spawn or open the app for you. And we'll also see why we use --no pause. The,
The video?
Yes, video.
Okay. Here you go.
Let's see.
Space.
Yeah. Let's see how this works. Right now, I have opened the browser, Android basic browser. It's not Chrome. It's the default one, which you get with Genymotion VMs. Then I just open this. As this is already open and Frida server is running in the background. That's why I get the output of the command frida ps-u. Then I could see that com.android.browser is running with the PID 4355. Now I try to get control of it. I copy the package name. Then I say, okay, frida-u, then the package name --no pause, and it gives me the console. Using this console, I could tamper the memory, or I could create something new, or change the implementations of function. We'll be seeing this later. But right now, we just attached to a running process or running app. Now, say for example, I close the app. What you can see is, you can see this message, failed to attach, unable to find the process. This one. Now, that is why we give -f, which will start the app for you and then attach to all the functions. Then you get the same console which we got earlier. Now one might get the question, why do we use no pause? It starts, Frida will give you the console to access its memory, but it requires the user to manually give this %resume to its normal execution, or else just wait and watch. After some timeout, Android will automatically terminate the process because the Android system thinks that this process is not working, so it automatically terminates. That is why we give --no pause, which means that just continue with the execution, don't stop anywhere. You're explicitly mentioning Frida to not stop anywhere and continue with the execution. Yeah, analyzing the command as usual. Frida, the name of the tool, -u is connect to the USB device. Generally, whenever you run an emulator or connect the real device to the system, it creates a USB bridge in which the communication takes place. That's why you mention -u, which means that connect to the USB device. -f is to start the app, and --no pause, as mentioned earlier, it's do not interrupt the app startup. Now we saw so many good things that you can implement new functions. I just said you can change the functionality, or you can stop the objects and so on. Let's see the syntax and semantics of how it gets done. Frida basically injects JavaScript engine to the target process as mentioned by Abhinav. So whatever you write, it can execute only if it is JavaScript. So you have to give JavaScript payload for the engine to execute. Frida comes with different APIs, which is well described at the official site. So if you're targeting, say for example, the payload what we write is not going to be the same for different architectures, or it can be say different process. For example, if you're targeting an app which is written in Objective-C, then you have to follow the API called Obj-C. Say for example, if you're targeting ARM machine code or program which is written to run on ARM, then you have to use something called ARM writer. Say for example, if you're targeting a program written in Java or which runs in Java, a virtual machine like that of Kotlin, then you are going to use Java for that. And the most basic payload is going to be this java.perform, and you define whatever you want to be done inside. So what does java.perform do? Java.perform actually takes whatever is being defined here, creates a thread, then runs it inside the virtual machine, Java virtual machine, and does whatever task you have like said that to do. Say for example, how if this is the Java function, if this is the Java class which I have to take control of, how can I take? You can see that it has the name com.name.app, the package name. Then you have the class called activity name. So this is what you're going to see not only in Android projects but general Java projects. All you have to do is use this special keyword provided by Frida API for Java, Java.use with the complete name of the class. The complete name of the class includes the package name along with the name what was given. In our example, the package name is com.name.app, and then we have the class name as activity name. Then we assign the result to a variable called activity. Right now, this activity contains the object of this class. Now, say for example, we want a function to be called, or we want a function's name, like function to be redefined. How do we do that? Say for example, we have a function inside the app, inside the package name with the same class name, and now we have the method name called function name, which takes an argument, a single argument, which is a string. How do we do that? We just go use the same variable activity dot the function name what was previously mentioned, function name dot use the keyword implementation which is provided by Frida to define the function what you want to run instead of the original function. Say for example, you write a function dot console log whatever you want to log on the console, then you just like run it on Frida. So whenever the function name is called, this definition what you have given is executed. In the backend, what Frida actually does for you is it starts the process. It's whatever definition you have given here is created as a thread and is created as a JavaScript wrapper and executed whenever the function name is called. Now, whenever we talk about Android pen testing or Android app analysis, it's not always closed source. Sometimes it may be obfuscated, but it's not always closed source. You find a lot of open source apps on GitHub. So I saw an open source dice game, which was pretty interesting. Yeah, this is the dice game. So what it actually does is it has two dice. So you have to press this button, roll dice, and it randomly creates. Whenever you get two sixes, then you get this message mission accomplished, or else you get this message try harder. I thought, why not we just hook or we just take control over the function and return always six? That would make us easily win the game without any effort or without any luck. This is the package name Chandrapal Bacha or Chandrapal.dice. And I knew that this was the entire logic was written under main activity. Because this is an open source app, I was able to see all the functions. So I just wrote, okay, implement whenever it's being called, just return. I take that, copy paste in the console. Now, whenever I press the button, I get the message mission accomplished with always six. Now let's try to close Frida. What just happens? The wrapper, the JavaScript wrapper, which was implemented over the process is destroyed. So it goes back to its original position where it just asks random to create some random or dice number and then goes to that. So for all who did not understand, let's analyze that. As I mentioned, there is an activity lifecycle for every Android app. The onCreate is the activity which is called just before showing you the screen. Now that called something called onClick listener, which was assigned to button. So whenever you click the button, onClick listener would execute. When that executes, it asks a function called random dice value. And what random dice value gives is it returns a random value between 1 to 6. It can be anything from 1 to 6. Now this also checks if the sum of the past two random numbers is equal to 12, then we just say mission accomplished. If not, try harder. That's what we got. So initially we were trying the sum of the past two random numbers was not 12. Then we got this message try harder. Our target will be this. Why? Because this is what returns the random number. Let's try to take control over it. What we do is set immediate. This is a JavaScript keyword which says that whenever the JavaScript engine is initialized, no matter you run other process, run this first, run this script first. Then you have Java perform, which says whatever is defined under this function, please go and execute. Then we create our own variable activity and we use Java.use, the keyword given by Frida, to get control over this class, which is Badshah Chandrapal Dice is the package name and main activity is class. Then we just log console log, which is nothing but a print statement in JavaScript. Then we go with activity dot random dice value, which is the function dot implementation. So we define the implementation to this, and we are no way going to say that you use the older initialize like older function. So we say whenever the button is being clicked, this executes, then you get the console log return 6, then this returns 6. In Java, there is another function, another feature I could say. This is operator overloading. If you heard of polymorphism, you would be familiar with that, which is you can have the same function name, but the content of the function, what is to be executed, is dependent on the argument which you pass. So you have another fn with argument as integer. You also have another fn with the argument as a string. If I say, okay, take control of another fn with the integer as argument, the initial method what I described will not be used, cannot be used actually. That is where we use another awesome keyword called overload. We do the same function, we create activity, then we say, okay, do implementation, which we are not considering right now. But our target function is activity dot another fn dot overload. I am overloading int, not string. Then dot implementation is equal to a function. I can define anything which will become a wrapper over this function. Now we saw we saw functions where it was hard coded that the logic was actually present. Whenever you click the button, that would get executed. Say for example, let's see this. You have a secret function which is not going to be called until you meet some logic or until there is some checks. On create checks this. Say for example, based on some logic example, anti-root or anti-VM detection, it calls this function and then it sets the value to the variable secret for future references. This can also be, say for example, dynamically generated passwords or private keys which are being generated. So after they meet some condition, they are going to be set to some variable. What do you think can be done right now? The private message, the private string secret is going to have whatever you require, the secret message or secret keys, what you are targeting. There are this can be the logic. So you have some random function which has nothing to do with set secret variable. Secret variable accesses secret and sets the secret to some secret, set some secret. How are we going to do? There are two solutions. One, the hard way, and other, obviously, the easiest way. So let's say we saw that on create, after some logic calls set secret variable. So the hard way will be use check what's the logic. If it's anti-root or anti-VM or whatever be the logic, you try to control all the functions or hook all the function logic functions and then wait for them to call this set secret variable, which is time consuming. And if you're dealing with a packed app or a huge app where you have calls from so many places, then you're going to get confused easily. The easiest method would be, why don't we just call this instead of waiting for other objects or other functions to call and then see what exactly is there in this private secret. So that is what is going to be our next demo. So this will be the easy solution. I just opened this app. I know that there is a secret inside because the source was already available, but I could not find it or I could not take control until the logic was met. What I do is I close this app. Initially, what we did is we opened the terminal, we connected or we attached Frida to the process, and then we copied entire payload and pasted in the console. Right now, we are going to save that inside a file called Frida.choose. Then we can see that we are going to call this Java.choose, which is a keyword which I'm going to explain later. Then on match, if something matches to whatever we are given here, then you continue with the logic. On complete, you can give whatever you want, whatever definition, or say for example, if you have to clean the code, what you have messed up with, you can do that there. Java.perform and Java.choose. Now I say -l Frida choose, which means -l generally means load the file instead of we typing manually to this package name. Now it launches the app for us. Then we get the contents of the variable. To your understanding that this function was not called by the app itself. We have explicitly called the function and then got what exactly was the secrets value, secrets variables value. Now let's analyze what we just did. We use Java perform. As usual, it's going to create a thread and attach it to the JVM Java virtual machine. Now we say Java.choose. Whenever we say choose, it is going to access the object which is in memory. It is not like use Java.use, which is going to create an object of its own. But instead, we use Java.choose this class. If this class is present in memory, onMatch executes. If yes, then console log found instance, the variable what is being passed, you just print that out. Then you say instance dot set secret variable, which is we are explicitly calling the function. Then we say why we use Java reflection. This is all, don't just confuse, this is just Java reflection to get the value of secret. This is a private variable, so we use Java reflection to get that, and we just say what is the output, what is the value inside secret. Now this is what the code looks like. You have a secret function, you had the function name which gets executed, but none of these functions is going to call secret function. This secret function gets called only if some logic is met or may not be called at all. This is how Java.choose works, which is on match. You have the definition on what you are going to do, and on complete. Okay, what are the basic use cases? What have looked till now? So initially we saw that we can try to attach to the process and get to control the variables what is being passed as arguments or control the return values. Say for example, I could see this mostly in root detection apps where all they do is they check most of the places where root might exist, the root shell may exist. Then they return true or false. True meaning the Android device is rooted, false which means it's not rooted. So what I generally do is I take control over the function. Whenever it returns true, which means the Android device is rooted, I just say false. The basic use cases include controlling the arguments, controlling the return values, like what I said, inspect the class variables, like what we did in the previous example, create objects of classes, and change the constructors of classes. Till now, we had seen two techniques. One was opening the command line, opening the console in which Frida was already attached to the process, and then copy the entire JavaScript and paste it in the console. Second was we put the JavaScript inside a file and we call that using -l. But now, wouldn't it be pretty awesome if there is some logic? Say, for example, a app is creating a private key and it tries to encrypt some values. Now we try to get the private key and do some logic with that. We can do that in JavaScript alone, but it will add more burden to Android device. It is efficient if we can take the required variable out and then change or do some operations on it and then return back. That is where Python comes into picture. Frida not only has in Python, it also has bindings in Node.js and Swift, etc., and C also. Frida has, yeah, and you can install if you're targeting Python bindings, you can install by using pip install Frida. This is really, really useful in automation or additional logic to existing variables or functions.
You have finished.
Yes.
Yeah.
Say, for example, this is an app. The logic is when I press the button, the initial message is going to change to hello YouTube. Now, this could be fair enough if I could take what is being sent to the function, the hello YouTube variable, and change it with Python. I know this is not a very good use case, but this is an example of how one could do it. Now, let's see how this works. All you have to do when you create a Python script for Frida is just type Python space the file name.py. It is going to control whatever you want to insert to the JavaScript or get from the JavaScript payload. Right now, we clicked on the button and we got voila hooked using Frida instead of hello YouTube. This is how it looks. We have a message handler, device, payload, node, and it is pretty easy for us to get confused by seeing all this. So let's see a sample Python code. This is a most basic sample Python code. This is not very simple or very small as that of JavaScript payload, but let's see. Let's analyze the code. You import Frida and you define a function on message which acts as a handler or a function which deals with all the messages that is being passed to Python from the JavaScript. Then you have the JavaScript which is going to be executed inside the app. In like you are sending the script to Frida. You get the devices. You get using Frida.getDeviceManager.enumerate device. What this does is it says Frida get the device manager, enumerate all the connected devices, which includes local, remote, and USB devices. Then you select the last one, which in most cases will be a USB connection. Say, for example, if you have two Android devices being connected, then the last one is going to be chosen. Then you spawn the app, that is, you start the app, which is the equivalent of -f in the command line. Then you say device.resume PID, which is the equivalent of hyphen hyphen no pause, which resumes the session like without any interruption. Then we attach to that PID what we got. PID is the PID of the Frida session of the package which is running. Now you get the payload, you create, which is the payload just means Java JS code. This is a wrong variable. This has to be JS code. Then you load the function. You just say that, okay, when you get something like a message, you use on message, that is the function defined here to handle that. Then you go with script load, that is load the script in Frida, and raw input might not seem important, but it is really important because if you don't put this, then the script is going to stop. The Python script is going to stop. What this means is till the user explicitly provides any message or presses any key, then you can stop the Python program. I talked about messages. Now let's talk about it in detail. In JavaScript, there are two functions which deals with it: send and receive. Send is used to send messages to Python, and recv, which is receive, is used to receive the messages from Python. On the Python side, on the Python script, what we are trying to write, we just say script.post, which sends or pushes the message to JavaScript, and script.on, which executes when it receives the message from JavaScript, and it actually handles it. By default, messages follow the JSON format. Whenever you try to send messages between JavaScript and Python, JSON is followed. And with the help of JSON, you can create different type of messages. Say, for example, if you want to create an error message that process has stopped, you can create that. Let's understand what exactly was in our Python file. We saw import, time, and Frida. Let's see how our message handler works. We have two arguments being passed: message and payload. You receive the data from JavaScript. Message dot get the payload. Data is what we are trying to send is voila hooked using Frida. Then we say print this on the console. Then we use script.post to send the message to the JavaScript. In this case, let's name our message as my data, and we pass the value pair as data, which is hooked using Frida. Now, device, we just get it using the technique what I mentioned before. It creates like it starts this app, it resumes. Then let's analyze our payload. In our payload, we use Java perform now or perform would work fine. We use this class name. Then we take control of this function, set the message content, and we implement. What we do here is whatever variable is being passed to set the message content function, we send that to our Python code. So it just gets sent and handled using this. Then whatever we get here gets handled here, and we post it here. We received, we get argument. This can be anything. So you just name it received JSON object, and we take my data from it, which is this. Then we wait till you receive a function, and then use the same function and set with the custom data what we have received instead of the original arguments which was passed. Real world demo will be given by Abhinav.
Thanks, Chandrapal. So yes, I think Chandrapal has given a lot of information right now around the basic uses of Frida, how the semantics look like, how exactly do we go about making our Frida scripts, right? So if I'm to summarize all of it in like a few lines, it would be the basic idea is very simple, guys. It's we make a JavaScript, the JavaScript that we want to inject inside our running process on the Android side, which is basically an app. So we make our JavaScript, we write whatever logic we want inside that JavaScript, like whatever we want to extract, whatever information what we want to extract from the Android process, we write all of that inside the JavaScript, and we inject this JavaScript inside the running process. Right now, there Chandrapal, he covered two different ways of doing it. One is you can directly open the Frida console, and from there you can paste your JavaScript right there. You could load it from a JavaScript file and do it that way. Or you could, if you want more control, if you want to automate the stuff, you can make use of the Frida Python bindings and have a Python program communicate with the JavaScript engine, which is injected inside the process. And this is made possible through the Python bindings, right? So what you start doing is you take your JavaScript, which earlier you were taking and directly putting in the console. You take that, now you make it as part of your JavaScript code, make it as a string, and then you use the various Python APIs, Python Frida APIs provided by Frida to send that particular JavaScript to your as an injection payload to the engine running inside, right? So that was the basic idea around it. And although so far we have been discussing about different apps, and all of these apps have been open source, which means that we had access to the actual source code itself, right? So we pretty much had the capability to go through the code, read it, and figure out what is happening, what is not happening. And it was kind of, a white box kind of thing, right? But I'm sure we would all agree that in most of our pen testing assignments, or in the real world case, so to say, we often stumble upon, or we have to deal with black box kind of situations, where we don't really have access to the source code itself, and we still want to do a binary instrumentation on that process, or we want to be able to control, so to say, as we've been talking about so far. We want to control a closed source app. It's running, and we want to control the flow of the app. Maybe we want to know internal variables, internal secrets if there are, and we want to do those kind of things. So it so happened that of recently a friend, he was kind enough to allow us to demonstrate this particular app, take it as an example, and demonstrate the use cases of Frida using this app. This app is again a closed source app. Closed source, so because there's an interesting story. It is closed source because this app was coded by this friend about 7-8 years back when he was in college as a college project. And although he had the APK now, he had the the binary now, but not really a binary, but he had the APK now, but he had somehow lost access to the source code. So it was actually a kind of closed source for all of us. And we wanted to analyze this app with Frida to see what can be done about it. Now, this app itself, let's just go about, take a look at it to see what the app is. It's again another game, and actually, let me go ahead and let's go about and take actually a look at the app itself. So, if we give me a second, guys. Right. So if you can see my emulator here, this is what the game is called. It is called Chicken War. And we'll just go through this app to see what it does. And it has got wonderful music, so let me turn that off. Yeah, so we'll go through this app. We'll try to analyze what it does. We'll just play with the app for a bit to understand its functionalities. And then we will look at our goals as to what exactly are we trying to do with this app, right? So yeah, let's just get started with the app. It takes a while with the banner and everything. Yes. So it has two modes of operation. One is one player, and then the other is two players. We have explored the one player option here, which is playing against a bot on the device itself, instead of the two players option, which is playing with another player and in which case the app communicates over Bluetooth. But we are not going to cover that. We are going to talk about one player mode, a single player mode, playing against the bot. The moment you play, you want to play the bot, you have to first play this classical rock paper scissors, where we try to win the toss and see what happens. So let's say I'm going to pick up rock, and it looks like I've won the toss. We get a grid. Let me pause here to explain. Okay, I don't know if you'll be. There's a timer running, so yeah. Okay, so there's basically a grid, and you're supposed to. If you have played Minesweeper, this is very much like it. Yeah, so we basically have a grid, and we are supposed to place our chickens on this grid. We have access to 5 chickens. It is the same that the bot also has access to. So I can place my chickens anywhere I feel like. So let's say, oh, I'm sorry, I'm right now in the attacking mode. So I have access to 2 rockets, and I can choose to place these rockets anywhere. Wherever I place these rockets, they will blast once the timer times out, or once I place once I press on ready. And if on the block, underlying block, wherever the rocket has been placed, on the underlying block, if the bot has placed a chicken, then we get points. Otherwise, we don't, right? So let's just press ready here. Yeah, so the bot basically had 5 chickens, out of which, 2 got blasted because there were 2 chicks over there. There were 2 chickens over there, and we had placed our rockets, right? So the bot is now left with 3 chickens. Now it's our turn to place the chickens, and I choose to just place it like this, and I place ready. So the bot has placed the rockets in locations where I did not put my chicken, so I'm kind of saved. So this keeps on going till the point in time when either of our chickens are all dead, right? And whoever has all the chickens dead first is the person who loses. Now, if you look at it, there's also another symbol here, which is called, which says into two. If you can look closely, this is basically shields. So it's a logic that says that I can place shields on my chickens. I can choose to use both these shields together in one chance, or I can pass it on to the next chance. Let's say I'm going to choose it both right now, and once it is used, there's no more shields left till the game is over. So I've used both my rockets right now, trying to shield 2 of my chickens from getting blasted out. If at all, the bot chooses to place its rockets over here, and I press on ready. So yeah, I mean, those 2 got saved, but the rockets were not there anyways. Yeah, so this is basically the kind of game, and this is how it all would look like. Let's quickly get done with it, and I'll explain why it is important. So right now, if you look, all of my chickens, all of the the bot's chickens were dead, and I won. So this was a lucky kind of a thing, lucky situation. I had not done any kind of a hooking, or I was not modifying, manipulating the app flow in any way. It was just a matter of chance that I won in this game. Right now, why was it important to go through this game till the end of the game? If Well, the reason is, if at all we want to do anything with the app, we need to understand the functionality of the app itself. If we want to use the powers of Frida, we need to know where to use the powers of Frida, which exact places in the app to hit, so we get our stuff done. And what exactly is it that we are trying to get done here? So let's take a look at that. We are trying to achieve a certain goal, which is to win the game every single time, right? Every single time, no matter what, we should be able to win the game, and that is what we want to achieve by trying to manipulate the control flow of the app itself, right? So far, the example that we saw, where I was playing it live, it was basically, it was not hooked, it was genuine. It was just a matter of chance that I won. But from this point on, let me actually try to show what happens if I actually hook the app and then play with it. What happens if I So I have a certain Python function written here, which is called hooker.py, which is the one which is responsible for getting me to win the game every time. It is this Python function, it is this Python file, Python script, that has all of the logic to send the JavaScript, to the to the running app, etc., etc. We will be looking into this hooker.py towards a little later from now. But for now, let's just see whether with this are we able to achieve the goal that we were trying to or not, and how does it look like if that happens. And then we go about breaking the hooker.py to understand what exactly happened. Right? Okay, so if I just run this right now, you should be seeing the app getting started. If you look at, okay, let me turn on the music here. Yes. So it says that there were two functions that were hooked. One was random, one was set protection. We'll discuss about all of these outputs. Right now, the idea is just to show a demo of how would a hacked application look like. One that we are controlling. So I'm again choosing one player. I'm choosing this. I won the game. I won the toss. I place my rockets. And if I place ready, I know that these are the first two places where the bot is going to place its chickens. Now, how do I know that? That is going to be interesting. That is where we'll be talking about all of the logic inside that hooker.py file. So if you see, those two places are blasted and the bot is left with just three chickens. It doesn't really matter where I'm putting my chickens, because end of the day, I know I'm gonna win. Blasting my chickens, it's fine. And I know I'm gonna put my next two rockets over here and say ready. Again, the next two chicks of placed by the bot got blasted out. It doesn't matter where I pushing my chicks, and I'm still left with one chicken, and this is my turn. So I place my two rockets here, knowing that the bot will place its next chick, and it's only chick left. Four are already blasted, if you see. So the last chick it will place over here at this rocket position. And as I said, how do I know that is the interesting part, and we will be discussing about it. So I just place ready, and that's where it blasts, and I have won the game. I can play this over and over and over and over again with this particular hooked up app, because it is an app which is hooked. It is hacked in real time. It is dynamically hacked while it is running. I haven't patched this code at all. So if I give you the same APK, it's not like you will be winning every single time, because this hacking is happening. This patching of the code is happening in real time, right? So that's how a hacked app would look like if I have scripted it, and if I have been able to hook through it. Right. So how exactly were we doing that? To understand that, we had to go through multiple steps, and I would like to break down those steps so that we get a clear picture of how exactly did we achieve what we just saw. Right. So there were multiple winning strategies. If you look from the first looks of the app, remember the first time I played the app in a genuine scenario? That's exactly what we were trying to do. We were trying to basically understand how we are playing, how the app is flowing through, and all of that. So there were two strategies that we could come up with. One was either I save all of my chicks from bot rockets, so place it in all locations, somehow figure out where the bot is deciding to place its rockets, and make sure that I'm not putting my chick in one of those blocks where the rockets will be placed. The other strategy was to blast out all of the bot's chickens before mine, right? So primarily meaning that I place my rockets in those grid locations where I know that the bot will be placing its chickens. And we chose to go ahead with this second strategy for our exercise. The problem, however, with this approach was that we did not know where, how, and when exactly was the bot placing its chickens, right? So if you look at it, and you would intuitively be inclined towards believing, or towards assuming that hey, when I'm starting off the gameplay, the bot decides randomly where to put the chickens, it places the chickens, and then I put my rockets on top of it, right? But that was not really the case. We did figure out, end of the day, which we'll be talking about next, how we did it. But we figured out that the bot never really pre-calculated where to put the chickens. So it was like when we place our rockets, after that alone, when we pressed on ready, it was then that the bot in runtime decided where to put its chickens, right? To the way we came about to this conclusion was by trying to decompile the app that we had. Now, when I say decompile, I'm saying we took the APK and we tried to recover back the Java source code from the APK. We tried to reverse engineer it from there to the actual source code, right? Because we discussed about it that this was a closed source project, right? For decompilation itself, there are multiple different tools that are available. All of these are open source tools. Excuse me. All of these are open source tools. Dex2jar, Njarify, Jadex. For this particular demo, we chose to go ahead with the Jadex. And the way you would go about decompiling an app would be just to pass the app name, which is chicken wars, this name here, apkpure.com.apk, to the Jadex binary, right? We're not going to discuss about the details of decompilation itself because that will be off topic. But yeah, this is how you would decompile an APK to its source. Once you decompile the app, you would get close to the source code. You may not get exactly the same source code back. So let's take a look at what were, after we decompiled it, what were some on analyzing the decompiled code. We figured out some interesting classes, some interesting methods, and let's take a look at those, the ones that we figured out. So when we started off, the first thing we tried to do was to figure out how to win the toss every single time. So whenever you won the toss, you would be in a position to be in the attacking position the very first time, right? And that was our first goal, or mini goal, to so to say. So remember, when the app starts, it makes you play the rock paper scissors game. So we tried to figure out what part of the code, the decompiled code that we had, was actually implementing, or actually appeared to implement that logic. And we found two methods. One was called start Yankin pawn, and the other Yankin pawn event on click, which was basically handling the logic of choosing, randomly choosing. It was making the bot randomly choose one number from 0 to 2, and all of these three symbols, the rock, the paper, and the scissor, were placed in three different indexes. So 0 to be the scissor, 1 to be the rock, and 2 to be the paper. And whenever that toss came about, the bot would randomly choose one of these indexes, and hence the corresponding thing, and did certain logic around that. So if we wanted to have this particular, the idea is, if at all we want to win the toss every single time, we need to be in a superior position in the toss every time. So conceptually, what we went about doing was, we said that, okay, whenever the toss thing comes up, we are going to always choose rock as our as our key. And then we would somehow make the bot, the somehow part is what we will be discussing again as we proceed further. But we would somehow, let's for now just call it somehow. So we would somehow make the bot choose the scissor. So because we have chosen rock, we have made the bot choose a scissor every single time in the hooked app. We will always win the toss, right? So that was the concept on how we went about figuring out how to win the toss every time. And I will talk about, we will actually look at the code and see where are we exactly doing that and how we are doing that, right? Okay, from here on, let's go and analyze another important or interesting class that we figured out. There's another class called chicken player status, and it was in the package chicken wars class. Now this particular class, it had we found that it had a bunch of private variables, right? So remember, a while back Chandrapal was talking about, if using Java.choose, if you wanted to look at all the private variables, the secret function thing that he was talking about, basically, if you wanted to look at the private variables of an object which is there in the heap at that point in time, you could use Java.choose capability, Frida's capability, to analyze those variables. We took this particular class in runtime, found that there was an object existing, and on analysis of these variables, we got even more information. With these methods in place, it was even more informative, right? Now, we're not going through the entire code and we're not discussing about the entire process of analysis, because it actually took a lot of time to go through the whole code, and going through that will take some time. So we're just calling out the interesting functions and interesting classes right now. And post this entire talk, we are going to release the app to all of you guys to play around with it. And feel free to take a look at these interesting classes on your own, right? Okay, so with that, okay, there was another very interesting class which we found, which had a method called set protection. And this particular class of this package, chicken wars class, it also had a variable called protection, which was false. Now, at this point in time, we didn't really know whether this particular method was the one that was actually setting the shield. You remember, while playing the game, we saw that there were shields available to a player, and the player could choose, beat me or beat the bot. The player could choose to shield its chick placed on the grid from getting blasted out from a rocket, right? So because this method said set protection, and because it was setting this variable protection to whatever is being passed to it, we thought of being a little wicked here. We thought, why not, let's just get the whole logic of protection out of the picture altogether. So whenever, be it us or be it the bot who tries to get protection, and if at all the bot tries to call this particular function, just ignore it, do not pass anything to it. So if we were not doing it, whatever is getting passed here, the boolean value true or false, that would go ahead and set this particular variable here. And apparently, if you go to the code, you would find that the apparently is not really apparently, but actually, yeah. So apparently, this variable will decide whether your chick is protected or not. So we said that every single time this particular function gets called, we are going to hook into this function, and they do not do anything, like do not set this particular variable at all, which would mean that neither the bot nor me, whoever is calling this protection, this set protection function, will ever be able to shield their chicken. Yeah, and again, that was made possible because of Frida. If you remember the last example that Chandrapal showed about how he was able to control the dice rolling function to make sure that it always returned 6, similar kind of a logic. And again, we will go do a code walkthrough of how all of this was done. Right now, I'm just giving a conceptual picture around it. So those are some of the very interesting classes that we found that helped us understand the behavior, or helped us sort of understand the behavior of the app, and help us strategize our master plan on how we were going to win every single time. So as part of our, oh yeah, I'm sorry, I missed one. So game mode.java was one more class. I have not put the screenshot here because it was a big class, and all of it was important. So so whenever you want to whenever you get the app, and if you decompile it, please take a look at this particular file. It is definitely going to be very insightful. It holds the majority of the chunk of the app logic, right? After analyzing all of this, our observations were that so although we saw that the code looked much like Java, but we have taken out only the important pieces of code from it, the interesting functions. But it wasn't even that straightforward as it looks, right? It was kind of cryptic in many ways. We had to literally spend hours trying to go through it to figure out the entire flow, right? But throughout this entire thing, one thing that we definitely observed was that a lot of random numbers were being used. A random number logic was being used consistently throughout the app. So Java provides a class called java.util.random, and we saw occurrences of java.util.random almost in a lot of places, right? So that gave us a feeling that random numbers is kind of important for this app. We have to win. We have to win the toss, and I just explained why. So we found that as another important observation. We also saw that basically we tried to hook into the random number function call itself and try to look at all the random numbers that were getting generated. And what we figured out was that the first random number that gets generated, it was for the toss event, which is the rock, paper, scissors. There was a second random number that got generated after that, which was basically being used to name the bot, right? Randomly choose something from 0 to 50 and append it with a string, and that becomes the bot name. That was something that we were not really worried about because we had nothing to do with the bot name. The third random number generation onwards, everything was in the gameplay, right? Which was basically controlling the placement of the chickens on the grid, or placement of the rockets on the grid by the bot, right? So the third random number generation onwards, it was all like that. We also saw that this code was not really obfuscated, like unlike most real world apps are, like, right? So if you look at any other real world app, you might find it being obfuscated using ProGuard or DexGuard or things like that. But this app wasn't, which was, kind of lucky for us. And as I mentioned, it was not. It was, although we spent some time. It was kind of cryptic, but we kind of got a hang of it. So with all of these observations, why were these observations important? First of all, because if at all, as I mentioned earlier, if at all we want to use Frida, and its powers, we need to know where to use the powers. What are the specific places where we want to use it? And the best way to do that is to do some recon, which is what our observations suggest, right? From these observations, we got conclusions. One which I have already drawn, which was that random numbers was what was all that this game was about. So and because the random numbers were generated in the same way consistently, that made it a very juicy target. Now, while Chandrapal was talking about all of the different ways, all of the different hooking of the different functions, it is not only restricted. Java, like Frida, does not restrict you in any way to hook only into the user-defined functions in your code. I could hook some very, very basic elementary calls itself. And that's exactly what we thought would be the way to go forward, where we would be hooking into the java.util.random class itself. We would be hooking into the next int method to be very specific of that class. That is the method that actually generates random numbers and gives it back, returns it back to you. So that was the plan. We would hook on every random call, and we would have some logic around it, and we will try to always change whatever random number the bot was generating to put its chickens, right? So and of course we have to win the toss every single time. That would be also as a proof of concept, and also make sure that we get the first chance to attack, right? We also made sure that we always bypass the shield placing logic, as I had explained earlier, right? So these were the conclusions we drew, and we came up with this master plan for the hack, right? So we place all our rockets and control where the bot will place its chickens. So if you remember a while back, I was saying it counterintuitive to what we were thinking. The bot doesn't place its chickens first and then allows you to put its rockets. Is the other way around. You put your rockets, and then the bot randomly decides which are the specific grid locations where it should put its chickens, right? And that happens only after you have placed your rockets and you have clicked on the ready button. So we decided that, okay, we know where we are putting our rockets. Let's just make sure that the bot, irrespective of wherever it has generated the random number to put the chicken, we are going to change that and make it place the chicken in the same location where we have placed our rockets, right, to get it blasted. We have made sure that the shields are never given out, and of course we place our trust in Frida for all of this to function and work properly, right? Let's take a visual look on how it would, how would the logic flow look like if we are going to change the placement of the chicken positions that is being decided by the bot. And if I am to look at it, just a second. Yeah. So this is the current state of the grid. We place our rockets in these two locations here. This is the first chance. and we press the ready button. In the ready button, when the counter is 0, the random number generated by the bot is something we don't care about it, but we change the random number through the hooking logic. We hook the random number generator, and we say that, hey, whenever it is the first iteration, return back 0 as the index where the bot should place the chicken. So we place the first chicken over here. The bot places its first chicken here. When it is counter 1, we make the bot place similarly its next chicken at this location, at the second index, right? So remember that every single time this is happening, the random number is getting called, the random number function is getting called. This random number function is what we have hooked using Frida, and we are discarding whatever the actual random number is being generated, and instead we are replacing it with the position that we want the bot to put its chicken, right? So in counter 1, when it is the first iteration or the second iteration rather, we are saying put in the chicken in this index. Similarly, in the third iteration, the chicken gets placed in location 3, 4, and then the 5. So now, by now, we have all the 5 chickens. We have managed to make the bot put its 5 chickens in the locations that we wanted, right? So that was the 0th location and this location, and then 3, 4, 5. These 2 locations already have our rockets, which means that the next step after all the chicks have been placed, the rockets fire, and once the rockets get fired, this chick dies, and these 2 locations also are now unavailable for the bot to place any more chickens, right? Now in this, so far now it is the bot's turn is done. Our turn, it was our first turn where we placed the rockets. We were the attackers, and the bot placed its chickens. It was the defender. It placed its chickens where we wanted. It is destroyed. Now it is our turn to defend and the bot's turn to attack, right? We don't really care about it. So the next 2 iterations is where the bot chooses 2 random numbers again to place its rockets and sends it back. So we don't really care about hooking those two iterations. We just let the bot put the rocket wherever it wants to put. So we just ignore the 5th and the 6th iterations and let the random numbers just be the same as it is being generated in reality. And after that, it's again, whatever had to happen happened. Our chicks died or didn't, whatever. We don't really care about it. The next turn is again ours to attack, and we know that these 2 locations are already destroyed. 2 chicks are destroyed. Now we put our rockets in these 2 locations, the next 2 available locations, and now we rig the game. We make the bot put its next 3 available chickens in this location, this location, and this location. And that is exactly what we do in the next 3 iterations of the random number call. So chicken 3 gets placed here, chicken 4 here, and chicken 5 here. And because we have placed our rockets already here, again, as soon as the 3 chicks are placed, the rockets fire up. The other 2 chicks of the bot are also dead. The bot is now left with only 1 chicken. Now it's again, once again, it is the bot's turn to attack and our turn to defend, which again we don't care about. Let it do whatever it wants to do. We just pass it over. So again, 2 rockets, the random number function gets called twice again to generate random numbers where the bot wants to place its rockets, right? So we don't care about it. We just let it go. We just ignore it. It's our turn again now to attack and to put the rockets. So we put the rockets in these 2 locations, which are the last 2 rockets that we have. And the last chance that we have, because we know that this will be the last chance, because we have been predicting, we have been controlling, rather not really predicting, we have been controlling where the bot will place its chicken. The bot is left with only 1 chicken, which will be placed here, and we make the bot place its chicken here where we have placed our next rocket. So in the next step, if you see, the last chicken that the bot has gets placed here, and the moment that happens, the rocket goes off and it is dead. This location also gets destroyed because the rockets go off together, but doesn't matter. This location doesn't matter to us, of no interest. Over here, we have killed the last chicken that the rocket had, that the bot had as well. By this iteration, we have managed to kill all of bot's chickens, while we don't really care whether all of our chickens are dead or not. And we could very well question that, it could be possible that the bot would manage to kill all our chickens first, but that wouldn't essentially happen, because that is why we chose to wreck the toss itself in the first place. So we always win, we get the first chance to attack, and we always win the game. So this is how the logic is going to look like, the whole conceptual logic of the hack in play. This is the master plan, right? Using Frida, we have one. Now let's see the master plan in. Okay, yeah, let's go back to the slide, and let's take a look at the master plan now in action, right? So we saw it conceptually so far, how we have programmed how we were thinking of programming the logic to always bypass the random number generated by the bot to place its chickens, bypass it and change it with our own controlled values, and those values will be where we have already placed our rockets. Now let's look at this entire conceptual thing in real world action, real world demo. I mean, we already saw the end result, so we'll see the actual console messages that we that what is going on behind the scenes when we are winning, right? Give me a second. Please allow me to pull up the video here. Right. So if you look at this, our game has started. We have hooked those two functions. So this is what it meant. If you remember, I was showing in the beginning. These are the two different functions that we have hooked. One is the random number function, the random number generator function itself, and the other one is the function that is, setting the protection and the shield basically. And with both these protections, what we are doing is we are, yeah, just a second. Oh, and after showing this, we'll walk through the code as well. So don't worry about that. Right now, we are just doing a analysis of what went on behind the scenes. So if you look at just a second, guys, the video is. Right. So we chose the one player. We made sure that we are choosing the rock over here because we know that we are going to change the first random call, which is for the toss generation. We're going to change that. And to like whatever it is, we're going to ignore that and we're going to change that with index number 0, which is a scissor, because we know we have chosen rock and we want to win the toss. And that is exactly what is going to happen here. Right. That is what exactly happened. So if you look at this console message over here, it says the actual random number that got generated in JavaScript was 1. So ideally, if we had not done this, the bot would have also chosen rock. But we said we passed that we passed that 1 from JavaScript to Python. Now we'll see how this passing happened. Chandrapal already explained about the send and receive functionalities. We will see that in the code again in action on how we did that. So whatever random number was generated in JavaScript, we passed it to Python. Inside Python, we know that we have received 1 as the output of the random number call. This is the first iteration, which means it is for the toss. So we just want to win the toss. Hence, we ignore what was generated and we return back 0 to the JavaScript. So we return back 0 to JavaScript from Python, and inside Python we see that it says that the new index received is 0, which means that now the bot is going to choose the item that was at index 0 instead of 1. Now, so instead of rock, the bot is going to choose the scissors, which means that we have already won the toss, right? After that, the bot generates a random number 3 again, which, as I mentioned, was for the generation of the the bot name, which we don't really care about. So we just let it go as it is. We pass it. We just pass it back as it was received. We don't care about that, right? And that's what I'm like just going through it over here. Um, Excuse that, guys. Just going through that. So we just passed that 3, which is for the name of the bot. Is the game start now, and from this iteration onwards, it is the same conceptual logic that we just discussed. We are going to put that to action. So we have placed our first 2 rockets here, and now we are going to change the actual random number generated with what we want. So in the first iteration, it will be 0, like the first chicken placed here, second chicken here, third, fourth, fifth, as we discussed. Let's look at that in the console to see if that really happens. Now, yes. So if you look at it, the first random number that got generated was 7. So the bot had decided to place the chicken at number 7. But we intercepted that call. We got that number 7 from JavaScript into Python. And inside Python, we said that, it is the first call. That means the bot is trying to place the first chicken. And we want to place the first chicken at the first grid itself. So it is our turn to attack. We say that, send back 0 as the index and not really 7 to the game. So we return 0 from Python to JavaScript, and inside JavaScript, it receives the new index as 0, and this is where now the game is going to place the chicken. And that's exactly what we do with the next iteration, which is 1. We make the bot place its chicken at 1. Same goes with 2, 3, and 4 in that order. So we have 0, 1, 2, 3, 4, all of these places controlled by us, told by us to the bot to place the chickens there. And all of this made possible through Frida's working library, right? And if you, yeah, sorry. So this is just going through it, right? So yeah, so this is where we have placed the last chicken so far. Now the 5th time the random number function is being called, it is not us who are the attacker. It is now that the bot is going to be the attacker. So the bot will try to place its rockets now, right? And if we look at just a second. Oh, and if you look at here, if you are able to see this, the bot was trying to place a shield. Either the bot or we were trying to place a shield. Now we know that we never tried to place a shield. The bot was actually trying to place a shield, because we see this function, the set protection function, being called with the argument as true. We simply ignore that. We don't allow the bot to put a protection at all. And after that happens, we have control over what gets blasted as well, right? So that is the entire flow. The same thing goes over and again. Again, we will be sharing across this script with you as well, so you can very well take a look at the console output yourself and relate it to the conceptual logic we just discussed. And that's how it flows about and makes us win the game every single time, because the concept that we discussed is what is being implemented in action over here, right? Now, this is what was happening in real time as we saw. Let's finally take a look at the actual code, right? On as to what exactly were we doing to make all of this happen. So let me open up my Sublime Text where we have the code. So just a second, guys. Pulling up. Yeah. So this is hooker.py, which is what we ran to initially start off with hooking into the game flow itself. And we have the chicken bypasser JavaScript. So hooker.py and chicken bypasser JavaScript. So these are the two things. These are the two scripts that we used. Let's quickly walk through these. Not a big, it looks a little complicated, but it's not at all complicated. It is actually a revision of the exact same thing that Chandrapal was discussing with you guys a while back. We start from here where we get the devices. Now you're pretty familiar with the syntax. We get the device, we attach our agent, so to say, inside the process, and whenever that happens, we send this particular JavaScript, we inject this JavaScript inside the running game. Now, what exactly is this JavaScript? Let's take a look at this JavaScript. This JavaScript, all it does is it says that, like by now we are familiar with the syntax. What is Java.perform? We know what is Java.use. So we are going to make use of the same constructs that we learned today earlier. And using that, what we are doing is we are saying hook into this particular class called java.util.random. And what method do we want to hook into of this class? This class has a method called nextInt, which is what gets called when the bot is trying to generate a random number. So we say hook this method and replace. So this method is basically an overloaded method, right? It takes multiple forms. The form that we are interested in hooking is the one that takes integers as an argument. So we say item.nextInt dot overload. This is the syntax, as again Chandrapal mentioned already. We say hook this method, which has the integer being passed as an argument, and replace its implementation with the implementation of my function over here. This is my function over here, right? And inside this function, all that we are saying is we are collecting the actual return value from the actual call, which is the actual bot locations, which is the actual check locations that the bot would have generated if we had not hooked it. We are pulling it out onto the console by saying this statement here, but we are not really passing it back. If you see, we are not really returning the actual return that we got here. We are returning a variable called cheat_num. And what is cheat_num? Cheat_num is received JSON object.mydata. What is received JSON object mydata? So we have, if you remember, Chandrapal was talking about a way which is provided to us by Frida, using which we can communicate between the injected JavaScript and the host Python. So receive is the function that allows the JavaScript, the injected JavaScript, to receive values from the Python side. By default, it receives JSON objects as its value, as its payload. We receive it inside receive JSON object, and we find out a key inside it, which is called myData. Now, myData is nothing but the actual number that we are controlling and which we are sending from the Python side. So we take this, we will see that in hooker.py. Let's just finish this off. So we take that number which is being passed from Python into JavaScript, and we put it in the variable called cheat_num, and then we are doing a bunch of console outputs to make it verbose, and we are returning that back finally over here, cheat_num. So this number finally gets returned back to what? Where is it getting returned? Not to the Python. It is getting returned to the actual process in which this JavaScript is injected, right? Meaning, this is the crux of what is changing the course of action of the bot putting its chickens on the grid, right? Now, let's talk about this myData quickly from the hooker.py. So hooker.py over here, if you see, we have another, yeah. Oh. 1 second, guys. I don't know where my, yeah. Yes. So over here, if you see, Chandrapal also spoke about another functionality. We saw what is receive, what receive does. Receive allows you to collect data in JavaScript, in the injected JavaScript from Python, right? The other way around, if you want to collect data inside your Python from your JavaScript, we use a function called script.on, right? And it has a predefined key called message. Whenever you get a message from Python inside JavaScript, there has to be a certain message handler, a function that will be called to do things on top of what you have received, which is what our message handler here is, which is called myMessageHandler. This myMessageHandler, what it does is it simply sees that what is the current iteration of the random number call, and it replaces the indexes as needed. If it is the zeroth iteration, then we pick up this particular value and we return this inside. We send this value to JavaScript. And the way we send this value to JavaScript is by using this particular function here called script.post, right? So remember we were getting my data inside the JavaScript here. See the my data. This my data is what we are sending from the Python over here. And the way we send from Python to JavaScript is through script.post. And what are we sending there? We are sending place bot check. We are sending place bot check at this particular variable. And this variable always holds the data that we want, depending on the iteration or the number of random calls that have happened, the nth iteration that we are on. Right, guys, I know this is like a bunch full, but trust me, it looks difficult. It isn't really all that difficult. If you take a little while to just digest all of this, we'll share across all of these scripts with you. If you take a while to digest all of this, just go through it once. I'm sure you will definitely get a hang of what is going on. But I hope so far we have been able to manage to understand, how exactly can we use Frida to to always, in this specific case at least, to always turn the game in our favor. And in general speaking, we can always control the flow of action or the flow of the process of the app itself, right? Using Frida, we have won the game. And yes, we did the code walkthrough already, and some most important aspects to note there was we used Frida for everything. We used it to hook random calls, we used it to manipulate the arguments or the return values. In this case, we were basically manipulating the return values, not allowing it to return the actual but what we wanted. We used Frida Python bindings to automate all of the stuff because we wanted to control the new index generated from our end. Now, one challenging thing that if at all you would want to try out would be to say, how on demand you can take this as user input, take an index from user input and change the course of action if you want to play around with this app at all. And we saw another very important thing, those four functions that Chandrapal was speaking about a while back, of communication between an injected JavaScript and host Python process. With that, I think like we have covered all of our demos. If you are interested in practicing it more, we will be giving away the APK to you. One of the goals could be possibly, so if you remember the strategy that we took, it was to blast out the bot's chickens all the time. And we were not really caring about our own chickens. We were just saying that, we will allow the bot to blast our chickens as well. But with this APK, if you want to try it out for practice, maybe what you can try doing is get a perfect score, right? Meaning none of your chicks get blasted. So one possible hint for this could be to see. So remember we were talking about the bot using random numbers to place its rockets, and we were simply ignoring it. Instead of ignoring it, possibly try controlling it and put it in indexes, in any two indexes. And now that you know the indexes where the rockets are placed by the bot, you always place your chickens in other indexes and not those two grids on the not those two indexes in the grid. The solution of this homework, frankly, we have to yet make the solution, but we'll try to get the solution posted if we can. And yeah, so please go ahead, and if you feel like trying it out, please do that by all means. We have some tips here. As we were, so if you saw when we were discussing about any of these things, Frida is just a tool, right? It's just a tool that gives you immense capabilities and huge amount of power to do whatever you want to do, right? But reverse engineering is more about understanding the functionality of the app. That's where we were, going through the deobfuscated, decompiled app, trying to understand its flow. Because unless we understand that, unless we do that kind of a recon, we are not really, we won't really know which functions to hook, what to hook, where to hook, what to return, what to manipulate. These things you will need to know by doing some reverse engineering exercises. It is suggested that there are many other tools out there, like APK tool is one of them, which you can definitely use to decompile your app properly and take a look at the entire app structure and things like that. And one gotcha, if you're hooking on the onCreate method, then you might have to minimize the app and then start it again. I'm like, we are running short on time, but you'd easily find the reasons for why this is so if you Google about it. We have the best resources over here. The best resources that you can refer to if you're trying to learn Frida. One would be the Telegram channel that Frida has. It is called Frida.re. That's trust us, guys. That is the best place where you can get and expect very quick responses and amazing support. Oliver, the author of Frida himself, is there. A lot of contributors to Frida core, to Frida libraries from the community are very active on the channel. There's always a new things being discussed over there. And in fact, if you go there, in our experience, you would figure out that whatever we have covered today is hardly a small pinch of the kind of capabilities that Frida has to offer. Now, there were plenty of blogs and Stack Overflow links that we referred to. We haven't compiled it here on this slide, but we will have it shared with the organizer of this discussion, and we will definitely request her to share it across with everyone. One last thing, we would like to give credits to three people in specific. To Oliver for allowing us to have such a wonderful tool out there that allows us to learn reverse engineering in a much more fun way. If people out there on this talk, if they have done reversing earlier, they know what kind of a pain it can be. But Frida does make it very, very fun. There's another guy who goes, another person, I don't even know whether it's a guy or a girl. The person goes with the handle tilt on the Frida Telegram channel, and credits to him because he really helped us out understanding a lot of basic concepts and helping us out where we got stuck. Credits to our friend Kenny, who was very kind to allow us to demonstrate his app to get hacked in public, a closed source app, and he was really sport about it. And in fact, he has given us permission to actually distribute the app as well. So we would try uploading the app in Google Drive. Again, the link and details of the same will be shared with the organizer. So with that, I think we have come to the end of the session, and I'm sorry we have overshot time by about 15-20 minutes. We have, if at all people want to go for question and answers, yeah, I mean, like, we'd be more than happy to answer. You can post them on the YouTube comments. You can send them to the organizer. She can proxy it to us, or you can reach out to us personally on our Gmail IDs, which is mentioned on the slide. Thanks a lot to OWASP for allowing us to give this talk, and the organizer for getting all of this facilitated. Right. Thanks, guys.
Thanks to both of you. Thanks to the amazing speakers. The session was really, really good. We've got really good chat responses that the session is going really good. Apart from that, they want the video to be uploaded. So it will be shared with everyone by tomorrow, along with the material that the speakers want to share. Apart from that, we also want to provide certain information about OWASP Bangalore so that people can get to know about what are the upcoming sessions and how they can actually contribute to OWASP Bangalore or OWASP, and how they can know about the latest news. So I'll just start sharing my screen. Okay. So this is the OWASP Bangalore Facebook page where we keep on posting about the latest news and all the events that are happening in that particular month. Apart from that, we also have a wiki which gives you all the information. What's our wiki page? What's our meetup page? What's the OWASP Bangalore mailing list? That's an amazing mailing list where we can ask questions, we can post questions, or we can talk about a topic as well where you want to know about some information. And if you want to speak, please feel free to reach out to us. We will be more than happy to have the same kind of a session from you guys. And apart from that, we also have a Twitter channel you can reach out to us via Twitter channel as well. And we promote diversity and inclusivity as well. So we really want more women to come forward and give sessions and be part of the bigger audience. Thank you so much, Badsha and Abhinav. Um, we will have certain questions for you. Let me just check whether there are any here right now.
Sure.
So right now, everyone says that it was an amazing session. So probably we will have more questions post the session, and if I receive it, I will pass it on to you, and would request you to share your material, which is demo and the source code, so
Sure.
that we can take help from it and practice it.
Sure. I think we'll hope both Chandrapal and I hope they will be able to answer the questions. If not, we'll definitely get to learn something from the community. And of course, we'll try to share everything as soon as we can. The slides, the demos, the source codes, the app itself, everything we'll try to share across with you. Anna.
Sure. I think we've just got one question
Sure.
before we close. The question is about the hard and easy way. While finding the secret message, what is the challenge on launching the easy way?
Come again?
Yeah, could you please come again with that question?
Sure. I will just post it on the Google chat.
Yes, please. Yes.
Yes.
About the hard and easy way while finding the secret
What is it?
message. What is the challenges on launching the easy way? Actually, if we understand the question correctly, when when demonstrating the secret function app, the easy way would have been to simply call that particular function which was there, setting the secret itself, and try to get access to that. Try to get every single, uh, as opposed to trying to get every single object that is out there, right? Every single function that is out there, trying to hook into it, and then figure out what is the one which is making the secret function variable set. Instead of doing that, we chose to do the easy way, which is we know that when the app started, this particular class has an object in the memory already. We know that the object has got a private variable in there already. And we also know that the variable is being set by a specific function alone, right? So it's very simple. If we get access to the object using Java.choose, and we call that particular method which is setting the variable, and just set it like that. So if we understood the question correctly, I think that would be the answer to that.
Maybe one challenge on launching the easy
Yeah.
way, what I feel is to find which variable you should target. In our example, it was
Yes.
pretty easy that
True.
we are targeting this secret function.
True.
But if you see real-time apps or malware, you have no idea which variable or which function to target. It's all, it's all verbose. It has no sense. The function names makes no sense. So you have to manually verify and then find, okay, what variable is being used, and finding the variable or function is the real challenge.
Yes. That
In
is
the
true.
easy way.
That is true.
You can see, say for example, if it's doing some anti-debug or anti-VM, there are particular tools to find what exactly is doing. Say for example, Rednaga's APK ID does that and says what exactly is being done. But there is no tool to find what is happening, what variable is taking what function, or nothing. So finding is the challenge.
Great. Let me check if there are any questions before we close. Great. I think we are good now, and we'll keep you posted if we have any more questions.
Yep. Thank you.
Thanks.
Thank you, everyone. Thank you for bearing
Thank
with
you.
us.
Yeah,
Uh,
2 hour session.
We hope we have been able to be of some help here, and hope to learn together again.
Yeah, that was an amazing session.
Thank you, guys.
Yeah. Take care.
Bye.
Thank you.
Take care.